Okay, everyone, welcome to my presentation today. How many of you guys have Facebook account? Okay, quite a few. So, like, how many have you guys have used Facebook to upload some personal pictures? So, have you guys like noticed like when you upload the image, Facebook can detect your face and you can tag those faces easily? So if you haven't, you can try it when you go after go back home. So today my topic is about face detection, so here's the some examples. So we can say like there are many pictures with people's face in the image, and we can say there's many bounding blocks here. So today my presentation is gonna explain what is face detection first. And then I'm going to explain in details how face detection works. And finally, I also will give some application for face detection. And if you guys have any question, please leave it to after my presentation, and I will answer them. Okay. So alright. So here's the overview of my today's topic. As I said, first I'm going to explain what is face detection, and then how it works, and then applications. So let's see what is face detection. Okay, very simple. Giving an image, okay, we have a person in here. The task of face detection is to draw a bounding box. It contains the face of the people in the image. That's easy for people, right? But how can we make computer to automatically do this? And so we can say how it works. Basically, it's very simple. So there are two steps. First is you train a face model, and then after you train this face model, you can use this model to detect the face from an image. Clear? So let's say the first step. We want to train a face classifier, which is the face model, which is also the idea is very simple. You can think of like all the image as a high dimensional point, okay? So, and you have all these face image, like as shown here as 3 face image, and here you have a bunch of non-face image. You can take from everything else other than face. For example, here's like some indoor thing. You can also have some like nature thing, whatever. Something that is not face, and somehow you find a boundary that can separate these two parts. And this is, you can think of like if mathematical view is going to be learn some function that can separate these two type of image. And in order to do that, you have to first to represent the image as some data, as some feature point. So a naive way is you just use the whole image. Say you use the pixel value of the image, and you so for example, if here's like 30 by 30 image, you can just use all the pixel value. It's going to be 900 dimension feature vector, like some high dimensional feature data, okay, feature point. And then you can train some classifier, say like SVM, if you guys know that. So you draw a line to separate these two data sets. So that's one way to design the feature for the image. But sometimes because of the illumination change of many other difficult problem, we also use like some feature to describe the face. Basically, you can think you represent each image as some feature. Okay, so for example, here are like 2 types of feature. One is like this rectangle. Upper is like black and bottom is white. So basically, you convolve this with the whole image, so you can transfer the image to some other feature, and based on this feature, you do the same thing. You learn a function to classify background and face. And so, in order to do that, we need to collect a lot of training data. So, for example, for this face detection task, you have to ask people to manually label a lot of faces. say you provide thousands of face image, and you also collect thousands of like non-face image, and then you can learn some function that can separate these two stats. Okay. Okay. So after we learn the face model, and we need to detect the face, how do we do this? We use a method called sliding window method. So it works like this. So suppose I first want to examine this size patch, okay? And then it's just sliding, and then you find the face. You examine every possible position of the image, and you try another one, which is of different size, of different ratio, and you do it again. And this time, it doesn't find the face because the score maybe is very low. But the one problem for this technique is you have to examine a lot of position and a lot of like size of the bounding box, or a lot of different ratio of the bounding box. So it's very time consuming. And how can we make it even faster and efficient? We use a method called cascade classifier. The idea is also very simple. So you think of like all these are like your input is all possible patches from the image, like different size, different ratio, and different position. And you first feed into the first classifier, and this classifier is very fast, but it's also very weak. So basically, do some very simple operations. Say, okay, so some patches they cannot be faced, so I discard them, and so it's going to be non-face, and then you keep those face, which is possibly to be faced. You feed into the next classifier, next layer. This classifier is going to be some stronger one using some better feature, better measure, and you keep doing this until like several layers later. So for example, here is like the very big classifier. Here is like you can use some strong classifier, but it's slow. But because here you have less image patch, so it's still affordable. So if we use this paradigm, we can achieve real-time face detection. So you can, like for example, my camera, it can detect my face in real time. And the framework basically is like this very classic measure. And here's some results. So we can say like for the weak classifier, because it's fast and you need to discard all possible patches. And here's a red one, which is like after 3 layers. And we can say the detection rate is very high. This axle is like the false positive, which is like the some face that is not face, but you detect the face. And this is the detection rate, which is like if it is a face, it detected correct. And the upper there, the better. Okay, so we can say like the classifier 3 is better. Okay, so finally let's go to see some applications. So as I said, like it's very useful when you like in the camera. So if you can detect the face in the image, you can adjust the lighting of the camera so you can capture the scene or the people better. And also like Facebook, it can help you to detect the face from the image, so you can help the user to tag the face easier. And also like for robot, if you can help the robot to detect the face, it can interact with you. Maybe like you can, after detect the face, I can recognize who he is. Okay, but the first step you have to detect where the face is in the image. So we can do some artificial intelligence stuff on top of that. So to sum up, so this is the message I want to deliver to you guys. There are 2 steps. First, you train a face model, and then you detect face. You train model, you use this face image, you non-face image, you train a boundary, and you train the detect face. You just use sliding window, using different size, using different ratio, and that's pretty much it. Yeah, to sum it over, I have presented how to train a model and how to detect the face, and also I have introduced the cascade classifier. So I hope it can also be useful for your guys' research. Now I'm open to questions. Yeah.
So you just talked about to find a function to separate the background and the face, right?
Yeah.
So can this function apply to like all the pictures or just? I mean, kind of, yeah. I mean, if we find this kind of functions, can we apply it to all the pictures?
Okay, so your question is like after I have learned some function, can I apply this function to all the pictures?
Yeah, so to detect the face.
Yes, I mean like so basically like so first you have to represent each image as some dimension of data. So you can first say like for all the image, I normalize the image to some certain size, like 30 by 30. Okay, so like you have to make sure all the data point has the same dimension. And if you do that, then after you learn the function, I mean just apply a new data point, right? And you give some score out of that. If it's higher than some threshold, then it's a face. If it's lower, then it's not a face. Does that answer the question?
Can this technology detect a face if the person is not directly facing the picture in the picture?
Okay, so your question is like if the person in the image has no like frontal face, then can my measure detect that? So okay, so I mean so because like as you're saying in my slides, so you train the model and you have to collect a bunch of data. So it really depends on like your data distribution. If all your data is like the frontal face, then maybe the function you learn, it can just distinguish like the frontal face. But if you also have collected many faces with like the profile face, and yeah, possibly you can like detect. But it also depends on the learning function, which function you learn. For example, many people use libSVM and like data boost. Some like classify. If you use different classifier, maybe they have different strengths and stuff like that. But yeah, it's also I mean it's still like ongoing research. But, it also depends on what feature you use to represent an image. So it depends on those things. But yeah, does that answer the question?
Yeah.
Okay, thank you. Okay, that was the 12 minutes, but I think there were, do you have a question? Yeah.
And additional
I just, you know, I'm thinking of the professor's end, because the professor, we tell them it's a 10-minute clip, so you don't want it to go on and on, but it's an interesting topic, so there's still some real questions, okay.
So I should
just
you
if you can answer.
I have a question about if we can apply the same model or same function to detect an animal's face or a bat's face or bat's form, something like that.
So your question is, can we apply the face model to detect some face of dog? Or?
Right, like you show a picture like with a woman with her dog, so
yeah.
can we use the same model to detect the dog instead of the woman?
Yeah, then basically you have to collect the face of the dog.
So that's a different model.
Yeah, and you have to learn different model. You can't like say you use your face model to detect the dog face. if you can use your face model to detect the dog face, then maybe there's some problem with your model. Okay, because yeah, human face is different from dog face.
Thanks.
Does it answer?